Hi, everyone. Welcome to today's summit, What's New in the AWS Cloud. This event was organized by the hardworking folks at AWS Insider and Virtualization and Cloud Review, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsors, SUSE and Alert Logic, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of 3 information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsors, SUSE and Alert Logic, have provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. As you leave the summit today, you'll be asked to take a very short survey. Sorry for the bother, but we would greatly appreciate it if you would share your honest opinions. Our editors read every comment, and they help to shape our future events. And last but not least, at the end of the third session, one lucky attendee will be receiving a new iPad mini with the A15 Bionic chip and the 8.3-inch liquid retina display. I've played with one of these things, and they're awesome. But you must be present to win, so stick with us. Now let's get started with our first session, What's New and Hot in AWS in 50 minutes. For this session, we've called on Stephen Smiley, AWS Solution Architect at Intervision Systems. Mr. Smiley leads Intervision's AWS consulting program, where he focuses on enabling innovation by making security fundamentals accessible and actionable, instead of a roadblock. A former military intelligence officer, he balances strategic and tactical thinking to help his company's customers accomplish their objectives. You are in for a great session. Take it away, Stephen.
Hey, thanks for having me today, John. Really happy to be here. This is such an interesting topic. You know, AWS is constantly releasing new stuff. We just had the annual conference, AWS reInvent, last month. And actually, we've even had some launches since then and in the months before. So it's tough for me to really compress down all the things that's new and hot in AWS. But I've tried to do that. And I've tried to do that through the lens of what I see with my customers working as an AWS consultant on a day-to-day basis. At Intervision, I lead a number of our practices. We do comprehensive security assessment and remediation. We do migrations. We do cost optimization. And my personal favorite is development of AWS native serverless applications. So the things we're going to see here today are some of the things that I'm interested in, the new and hot things. And without further ado, let's jump into it. But I do want to invite people to submit any questions that they've got into the Q&A box, and I'd love to answer your questions either during the session or at the end. So let's get into it. Here are the top 10 things that I'm looking at on our agenda today. So the first one is a major price reduction on data transfer out of AWS. One of the first things you learn about cloud is that data transfer in is free and data transfer out is where they get you. Well, AWS has tried to make that a lot better, actually. There was a recent price change or a service launch out of Cloudflare where they introduced very low-cost data transfer out, and AWS responded quickly and very powerfully. So now, if you're using CloudFront, that's their content delivery network, you get free monthly data transfer for the first terabyte of data out. You get the first 10 million HTTPS requests and the first 2 million CloudFront functions invocations. That's all free per month with no time limitation. And that's huge. The vast majority of customers won't ever actually go beyond that limit unless they're really scaling out. And so a number of people just saw their CloudFront bill drop to next to zero here for data transfer out. And then for regular regional data transfer, you're now getting the first 100 gigabytes free per month. And again, that's got no time limitation. That's not just for the first, 6 months or a year. No, that's ongoing. And for a lot of people, that means that their data transfer bills are going to drop next to zero. So that's pretty huge. Yeah. The next thing to know about is S3 Glacier Instant Retrieval. So S3 is everybody's beloved AWS service, the simple storage service, and S3 standard is where most of us drop our data, especially if we don't really know what we're doing with it. But for a long time, Amazon has had this Glacier service that's been integrated tightly into S3, where you can store that same data at a much, much lower cost, but it's kind of hard to retrieve because it's really supposed to be just for archival, and you would retrieve it by exception. The problem is, and I experience this all the time, is people say, okay, well, I want to send my data to Glacier to have this cost savings, but then a couple weeks later, they want me to pull it back out, and it's painful. And then a couple weeks later, they want me to pull it back out again, and I have to go through the same process again. I have to request it to be restored, and then we have to transfer it, copy it. And it's really painful. And actually, you end up paying for those retrievals, and that's just not ideal. So they've actually renamed that old storage tier to Glacier Flexible Retrieval. And now there's this new tier called Instant Retrieval. It has the same latency and high throughput performance as S3 standard, but it has up to 68% cost savings compared to the standard infrequent access, which was the tier in between standard and Glacier, right? So that's a pretty huge difference. I've got a little chart here on the screen about what class should I use. If you're going to access your data once a quarter, then Glacier Instant Retrieval is the best choice. You're going to get the lowest cost, and you're going to have just as good performance as you would with standard. If you're going to access it a little bit more frequently, then standard infrequent is the way to go. That's about once a month. If you're accessing your data more than once a month, you want to stick with S3 standard. That's just where you're going to get the best cost optimization here. If you're not sure yet, then stick it in intelligent tiering. AWS will based on will choose the class based on your usage pattern, and it can actually use the same classes that we mentioned above. It does have slightly different names for them. It calls Glacier Instant Retrieval Archive, and it calls Standard Infrequent, and it calls Standard Frequent. So the names get a little confusing, but if you don't know, I highly recommend you just use the intelligent tiering class, and you'll be able to take advantage of this without really any effort on your part. So pretty big announcement there. Another one, and this one really slipped through the cracks of lists of announcements that came out of reInvent, but you can now archive EBS snapshots, and it comes with a recycle bin, so you can pull them out if they were accidentally deleted. So previously, you could take an EBS snapshot, and you were charged the normal price for storing that snapshot as long as you held onto it. Well, now you can send it to an archive, and you get up to 75% lower cost, which is really great because a lot of people keep snapshots way longer than you might think, either for compliance reasons or they just want to preserve state at the end of a project. They want to go, okay, this is what I had on my disks when we finished the project, and I want to keep that for 5 years or longer. Okay, that's fine. Send them to the EBS Snapshot Archive, and you can save a lot of money. Retrieval does take 2 to 3 days, so you have to, ask for it to come back, and then once it comes back, you can copy it out of the archive tier. But for most people, for compliance reasons, that's not going to be a problem at all. So the other feature here is the recycle bin, and in order to take advantage of the recycle bin, you have to configure a retention rule, which you can choose to be between one day and a full year, 365 days. And you can have it select all EBS snapshots that get deleted, or you can do it based on particular tags, right? So a good practice is to tag your EBS snapshots based on the application or their backup needs or retention needs. And so if you use tagging there, then it will grab those deletions, put them in a recycle bin, and then you have to look at the recycle bin to restore them if you want to recover them. But one of the things you should know is that you can't restore it directly, so you would need to initiate a recovery, and then you can get it back. You can't restore a EC2 instance directly off of that archive or directly out of the recycle bin. And you should also know that you're going to pay full price while they're in the recycle bin. I fear this is going to trick a few people incidentally, where they're going to go, oh, look, I don't have any EBS snapshots. Oh, but I've got a recycle bin rule that's retaining it for a year, so I paid for hundreds of snapshots for a year. So be aware of that. Think about it when you set a retention rule. But I think that a lot of teams are going to get use out of this. Okay, so the next thing I want to talk about here was IAM Access Analyzer. And this isn't brand new. This actually came out a couple months ago, some improvements to IAM Access Analyzer. But I really want to continue to evangelize this feature because I think this is one of the trickier parts of using AWS, is writing IAM policies. So Access Analyzer helps you identify permissions and resources that can be used by external entities, right? So if you've got a S3 bucket or an IAM role or something like that, Access Analyzer can help you figure out who else can use this. Can an external account use it? Which one? Oh, okay, that's my account. That's fine. Wait, which account number is this? I don't remember, right? So IAM Access Analyzer will help you figure that out. And it can also help you be sure, like, okay, yes, this cannot be used by any external entities, which is pretty important to a lot of people, right? So another feature that it can do is policy validation. They've got over 100 checks that will help you kind of lint and check for security your policies. So some of those might be simple things like, oh, you forgot a bracket here, and that's why this policy is not validating. Okay, that's really helpful to know right here. So that's just simple linting. But it can also do things like security checks. So I've got an example on the screen there that it's detecting IAM pass role with star in the resource, which means that this policy allows passing any role to any resource, which is pretty dangerous because if I have the ability to launch EC2 instances, I can launch an EC2 instance, pass it the role of administrator, and then when I log into that EC2 instance, I have administrator privileges. So if somebody tried to limit my permissions, there you go. I just got around them. So this is one of the most common security flaws that people write into their policies, and Access Analyzer will detect that for you right there. And then probably the most powerful thing to come out of Access Analyzer is the ability to generate a least privilege policy based on your actual usage. So we've all got a cloud trail set up for all of our accounts, I'm sure, that would be a security best practice. And then periodically, you can go and look at your IAM users and roles and say, give me a policy that only allows the actions that they've done during this period of time, right? So The way I use this is I'm building a new application, and I don't want to keep running into permissions issues along the way, so I give myself really broad permission. Okay, now I've built it. I've kind of finished using it for 30 days or so, and I'm going to go generate a policy that says what is actually in use, right? Like, now that this is running and I'm no longer tinkering with things, what IAM actions are really necessary? And then I'm going to use that policy for the future. So that helps me refine my policies, and I'm not leaving those broad permissions in production for a long period of time. So that's previously we've used third-party tools for that, and it's really nice that AWS is giving that to us right here in the console or on the command line. Okay, so let's talk about the next feature, which is the web application firewall bot control feature. A lot of people use web application firewalls for simple rules, simple protections, but one of the things that they get is a lot of traffic coming from bots. I mean, 51% of traffic hitting your web apps is coming from bots. And it's not all bad, right? Some of it could be that it's a search indexer. And, you know, if you're running a public website, you probably want to be search indexed. So that's fine. But you might want to block things that are, you know, scanning you for vulnerabilities, or just taking your resources, right? So WAF bot control analyzes TLS handshakes, HTTP attributes, and the source IP address using their intelligence, and gives you the ability to either block those bots or return them a tailored response, or, you know, insert a new header into the page that you return to them. I think the most significant thing here is that this can help you reduce cost and save performance. So if I'm running a web application that's on a fleet of EC2 instances that's got auto scaling, because I want to be able to scale up to meet whatever the traffic demands are, I really don't want bots forcing my auto scaling up and letting me pay for those EC2 instances, right? And I don't want those EC2 instances serving a bunch of traffic to bots that I don't care about. So I'm going to use WAF bot control, and I'm going to block them at the edge. They won't ever reach my EC2 instances, and my scaling is only going to be based on the real traffic that I care about. I think the best part here is that the pricing is super reasonable. At $10 a month plus $1 for 1 million requests, and a generous free tier that covers 10 million requests, most people aren't going to be paying any significant amount of money for this. So it just takes a little bit of configuration, and you're protected from bots. Okay, so the next feature here is App Runner. And this is one that has gotten some attention in the AWS community, but it's been a bit tricky to figure out, you know, when would I use this versus other, you know, container services. So App Runner is the simplest way to run a containerized app. This is actually the result of combined efforts from the container service and Elastic Beanstalk teams, where they got together and talked about some of the common patterns that they saw and made a whole service just for those common patterns. And so you can see here on the screen that App Runner lets you select a source and your deployment, right? So you can choose either a container registry, right? If you're serving your app right from Docker or from ECR, or you can point it right to your source code repo. So you can point it right to your GitHub and say, okay, connect, look at this repository, this branch, and on changes to that branch, go do a new update. So right away, you've got continuous deployment out of GitHub with no special configuration. And then you'll also configure the service settings. So you'll say, this is how much virtual CPU and memory I want to give it, and these are the environment variables. So you can have a branch that's for your dev environment. You can have one for your staging environment and production, and you can have different deployments based on those with different keys and values. And so your application can just read those environment variables and adjust as needed. So for a lot of people, like, this is going to be a super easy way to get started on AWS, get continuous deployment. You're automatically going to get a public endpoint with all the supporting infrastructure. And I just think that a lot of people are going to get a lot of use out of this rather than having to learn the ins and outs of ECS or EKS or any of those other services. And then this can also be combined with other things. You know, AWS has app to container that'll help you containerize Java and Spring Boot applications. You can even target App Runner from AWS Copilot. So this integrates with a number of other AWS services and features. I think a lot of people are going to find good use for this. I want to address the question of, is it right for me? So there's lots of ways to run containers on AWS. And I think comparing it to these two most common ones is useful. If you compare App Runner to ECS on Fargate, App Runner lets you build and deploy directly from your source code repo, which ECS is just not going to do. And App Runner will give you a public endpoint with all the supporting infrastructure, but it's important to note that you're not going to get any control over the VPC that it puts your application in. So if you need that additional customization and control, then you do need to go to ECS and build those things out. But if you don't need that right away, then get started with App Runner, right? And build that on the side if you need to. Compared to EKS, their Kubernetes service, App Runner is really intended for much smaller apps. Kubernetes introduces a lot of overhead. It's really intended for much bigger teams than App Runner is. The major difference here is that you're not going to get any of the Kubernetes ecosystem. So for some people, that's really important, right? If you really need the ecosystem of request tracing and logging and, you know, all the other stuff that Kubernetes has, then App Runner is not going to be the way to go. But I would be surprised if most people actually need all that stuff. Most people can probably get started on App Runner and prove out their business well before needing all of that extra complexity. So let's take a look here at the new application migration service as well. This is something that I deal with a fair amount in my business of helping customers migrate into AWS. So AWS acquired Cloud Endure all the way back in 2019 now, and we've been using it, and it's been good, but one of its major issues was that it wasn't really integrated with the rest of AWS. And so now it's been integrated, rebranded, and it is the primary migration service. So while AWS still has the server migration service available, I really recommend that you stop using it. It's just not as robust as application migration service. And so that's really what you should be using. I have a couple of screenshots here to show you how simple the process is, because really all you're going to do is install an agent on source servers, and it will continuously replicate those systems to an AWS staging area. And it does it a staging area with kind of lower costs, so you're not paying for a bunch of infrastructure that you're not using yet. And then when you cut over to production, it'll actually scale out that infrastructure and run it at full capacity. The pricing on this is pretty interesting because it's free for 90 days, except, of course, the infrastructure that you're provisioning. So you're not paying anything extra for the service. 90 days, depending on your perspective, might be a long time, and it might be a very short time. But in my experience, we've done a lot of migrations, and I really, really recommend getting your migration done in 90 days or less, unless you're a really, really huge infrastructure team. If it drags on too much longer than that, you're going to get stuck in two worlds. You're going to have lots of overhead, and I really don't recommend that. So I think the pricing here is great. Get it done within those 90 days and don't pay a dime for it. Here's some screenshots of what it looks like when you're using it. So you'll add the servers. They've got pre-made scripts for just about every source server you can think of, and then they'll be registered in here, and you'll get a little view of their different statuses. As you go to configure each one, you can set the launch settings. You can say, okay, what instance types do I want? How am I going to have licensing for Windows or whatever the operating system is? Do I want to copy the private IP that I was using, or can I get a new one? Do I transfer server tags, or whatever it is, right? You can set this up however that server is going to be, and then you get a chance to test it, launch it into the test environment, make sure everything's working right, and then you can cut it over. So you can, and then also if you encounter issues while testing, you can just revert it really quickly. So application migration service makes migrations a lot easier, and I think that a lot of customers trying to move into AWS are really going to find this to be a much more pleasant experience than what they've had in the past. Here's a view of the dashboard that you get as you migrate. You can go through the different stages of, okay, this is ready for testing. We're testing now. Ready for cutover, right? Cutover complete. And this is just really nice because everybody on your team can keep track in the same place, and you don't have to build Excel sheets to keep track of these things, right? Which is what most people are doing. So this is all sourced by the real data and in one authoritative place. And I think that is a really nice experience. Okay, so another service here is Incident Manager. And from my perspective, this fills a major gap in the AWS offerings. For a long time, AWS has had SNS. It's had different ways of notifying people. And yeah, you could tie things in with CloudWatch alarms, but there wasn't a great way to centralize management of incidents, right? And so a lot of people use third-party tools. And if you have things in many places, not just AWS, yeah, a third-party tool still probably makes sense because Incident Manager is mostly going to integrate with AWS. But if you do have all your stuff in AWS, then this is a great place to have a centralized incident management, log and response system. So what you'll do is you'll define contacts and channels. You'll say, here's how to reach Steven, for example, and here's the ways to reach him. You can call him, you can email him, you can text him, whatever. And then set up escalation plans. It's like, all right, send him an email. If he doesn't, respond, go to this, right? You can go to, if Steven's not available, call Joe, right? So you can set up these escalation plans right there in Incident Manager. And you'll also build run books, and you'll even have a collaboration channel. So you can chat with your other people right here in Incident Manager so that you're not on the fly coordinating, okay, let's create this Slack channel, you call me, who's calling who, and all of this gets logged right there alongside the rest of the information about the incident. And then you'll also set response plans to be triggered either manually, which would be the simplest way, but also you can do it through CloudWatch alarms or EventBridge. So you can say, okay, we've got some screenshots here, high latency of DynamoDB write. Like, okay, my database is really is really having issues. All right, let's start an incident, and then it's going to keep track of all of those events. This, so you've got your run book of how to handle it, but then you're also going to kind of take notes, and then after the event, you can say, okay, how would we have detected this earlier or better? How would we have prevented it? And the layout of this is based on AWS's extensive experience in handling incidents for their infrastructure. So that helps out a lot. They've dealt with this plenty. They've done a very good job of handling their incidents, and let's learn lessons from them. Okay, let's talk about the next one here, which is Step Functions Workflow Studio. If you are using AWS and you're not evaluating their kind of serverless services, I really think you're missing out. So everybody that talks about serverless knows about AWS Lambda, and we'll talk about DynamoDB as the serverless database. So those two go together pretty well. But I feel like not enough people are talking about step functions and its essential nature for orchestrating flows through serverless applications. One of the major improvements that they made to step functions recently is that you can use step functions for any AWS SDK or like API call, okay? So previously, a year ago, step functions only had a handful of particular actions that it could take. And now it can do anything that you can call with the AWS API. So right away, the vast majority of Lambda functions that were just doing simple things without any special logic can be replaced with step functions, and it's a lot easier. But then more than that is you can write a step functions workflow that combines those actions, has logic built into it and error handling built into it, all in one step functions workflow. So the service is great, but the intimidating part was writing these workflows because you have to do it in the Amazon state language. And so it's like, okay, how do I do that? Well, Workflow Studio will address that problem. Well, you can take a look here of what it looks like, but it's basically a drag and drop editor. So you've got a start and an end, and you can just drag and drop these different actions or flow nodes and build out what your workflow is going to be. So here we drag over, validate account data, and then we get on the right side all the configuration options for that. So we've got, all right, this is going to invoke a Lambda function. What is that function going to be? And then we'll configure the input and the output that it gets. And that input can come from the previous step, and the output goes to the next step. And along the way, you can transform it however you want. So you can only pass particular things to the next step if that's all it needs, or you can transform its schema so that the next one can handle it in a cleaner way. And then along the way, you can introduce logic rules. So you can say, okay, let's introduce a choice. And based on this input, I'm going to determine whether or not I'm going to store the account information or send an email that says that this failed, right? And so you can handle your errors right there in the workflow. And this is just a lot better than trying to write a Lambda function that captures all of this. It's also just going to be easier to evolve over time and reason about, right? If you were coming in to maintain an application, what would you rather have? This visual ability to understand the workflow, or have to kind of reverse engineer somebody else's code? I think that the step function is going to be a lot better. One of the things to know about it is that it's really just for creation of your initial workflow, however. So at the end of that, you're going to export the result to JSON. You can store that in your source control, which is really the best way to do it. And future modifications would be made to the code here. So you wouldn't come back into Workflow Studio and make changes later. But you can regenerate diagrams based on this code using other tools such as the Visual Studio Toolkit. Okay, let's talk about another thing, especially when we're talking about serverless applications. The Cloud Development Kit just launched version 2, and that went generally available just about a month ago. So CDK, the Cloud Development Kit, is a way of defining your infrastructure using regular languages, general purpose languages like Python or TypeScript, You could even use C# or Java, and they've recently added Go. So there's a lot of different languages you can write this in. And it generates, or it kind of transpiles into CloudFormation. So it's just a more familiar way of writing it, but it's using CloudFormation under the hood. And my opinion is that this is the best way to develop new applications in AWS. And I really think that this is the future of infrastructure of code. This was a major topic during AWS's CTO's keynote. That's Werner Vogel's. And I'm on board with him that this is the future of infrastructure of code, especially if you have developers that have a preferred language, they're writing in Python or TypeScript on a daily basis. Let's not make them learn another, format for CloudFormation. Let's let them write their infrastructure in the language that they're familiar with. Another reason that I think this is the best way and the kind of the future is that the lines are becoming quite blurred between infrastructure and application, especially as we talk about serverless applications, right? So step functions has my business logic, and it's storing things in DynamoDB, and it's like, well, which of these is my infrastructure and which of these is my application? Well, the line has gotten very blurred. So we should be using regular application development tools as we build our infrastructure that supports it. Another reason that I think this is the future is that the real languages provide pretty unmatched power, concise expressiveness, readability, and testability that CloudFormation just never really had. So you don't want to go too crazy using your language and produce so much of stuff that's hard to reason about, because that's really not good with infrastructure. But being able to, do a for loop and loop through a number of things in an array, for example, that's just everyday stuff for Python, but it's really difficult to do in CloudFormation. It's also easy to express yourself in a regular Python language by saying, okay, I've got this Lambda function, and I'm going to create this IAM role. I'm going to attach the role to the Lambda function, and I'm going to let the Lambda function put data in a DynamoDB table. And the way that reads in CDK is much more straightforward than it is in CloudFormation, where each of those things is totally in separate nodes, right? Separate objects. And so I think that we're both writing it and reading it is much better. The other thing is that as CDK does a number of things for you, right? It will help you generate least privilege policies implicitly. It helps you enforce best practices by default. So in a lot of cases, if you don't provide a value, it knows what the best value is, and so it will do that for you. You still have the responsibility to understand what it built for you, but it's going to help you not make mistakes. Another thing is that the deployment pipeline can really be part of the application. So CDK pipelines lets you describe how that application gets deployed, and you can source control it and write it as all as part of the same application. It's much easier to do than separating it out to several different tools. And even though CDK is relatively new, you always retain the ability to just use CloudFormation right there in CDK. So while CDK has a bunch of features that are on top of CloudFormation, you'll never really sacrifice anything that CloudFormation does have natively. So that's what I'm using for all of my applications, and I encourage you to as well. We talked a little bit about these different features that CDK adds on top. So it has a concept of constructs where level 1 is just raw CloudFormation basically, and then level 2 would be these curated components with sensible defaults and best practices built in. So whenever possible, you want to use those level 2 things. And then level 3 would be patterns of multiple resources that you've integrated together. And this is where you would be mostly writing your own things. But you can write your own and then spread it across your organization and say, hey, this is how we want to be doing, ECS deployments, for example. Now, you don't have to go and rebuild this. We've built a CDK library that we maintain on how to do this. So that's pretty exciting to me. I have a short example here of what it looks like to run a highly available containerized web service with an internet-facing load balancer on Fargate. And you can see that in just 29 lines of Python here, it's going to generate over 1,000 lines of CloudFormation to execute that pattern. And it's doing so by leveraging this ECS pattern dot application load balanced Fargate service construct that's available in CDK. And all I'm doing is saying, hey, this is how much CPU I want. This is the desired count. This is the task image, right? So I'm just giving it directly the parameters that I need, and it's going to do a lot of the heavy lifting for me. This is just going to help a lot of people save time and build much better infrastructure. So that is my top 10 things of what's new and hot in AWS. I look forward to your questions. I'm happy to answer anything you've got. What do you have for me?
Stephen, you got it done in with 5 minutes to spare. Before we got started, Stephen was worried that he had too many things because there was so much going on, and he wouldn't get them all done in 50 minutes. But you did it. You did it.
Yeah.
Well, okay, folks. So we're ready for the Q&A. Let's get to some of these questions for our attendees. Remember, you guys, you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Let's see what we've got here. Let's start with this one here. When would I use step functions when I can use Lambda?
That's a good question. So step functions is going to help you orchestrate workflows much better than Lambda can. So if I've got a task in my Lambda, especially things that are like asynchronous or long running, if I've got something that's going to go and take 15 minutes, well, that's going to time out in Lambda. And step functions, that's no big deal. Step functions workflow can run for a whole year if you want it to. So that's one way to do it. And then also just for any Lambda functions that are really just, calling a couple of APIs and not doing any significant logic or, data transformation, then I would make those step functions, hands down, no question.
Gotcha. Okay, we've got one here from Rabik. He's wondering, are we able to use Terraform with CDK?
That's actually a really good question. And the answer is yes. There is such a thing as the, what I think they call it, the CDK for Terraform or CDK TF. It is not as mature as the regular CDK, but it's on the way. And there's a lot of advantages to that, especially if you're already kind of a Terraform person and you've got your mind wrapped around that. That's great. One of the limitations, if you will, of CDK is that it's always tied to CloudFormation, which means all the deployments are through CloudFormation, which means that any limitations in CloudFormation still exist within CDK. So we just have to be upfront that is the situation. Now, there's a strong counter argument, which is CloudFormation has those limitations for a good reason, right? It takes longer to do a deployment in CloudFormation than Terraform because CloudFormation is trying to do things more safely. And so that's one of the reasons that many people prefer CloudFormation over Terraform. But there's some disadvantages. I mean, so one of the things that I experienced recently, for example, is I was trying to make a Active Directory, I was trying to deploy Amazon Workspaces with an AD connector and I found that there was no way to connect that directory to workspaces just through CDK, right? So that's not a super common thing, but Terraform has the ability to do that. It has an API action for that. And I had to use a CloudFormation custom resource to do it, which is a bit more of a headache. So there's trade-offs there, and I'm hoping to see that CDK for Terraform continue to mature. I'll keep an eye on that for sure.
Thank you. So Stephen is wondering, why does config not record configuration changes to global resources such as CloudFront?
Oof. I mean, if you're going to ask me a why question like that, I'm not the right one to answer that, right? Like AWS has to figure that out. But I think the simplest answer is just that config is a regional service, and those global services don't mesh well with that. I think that's the simplest answer. But of course, even those global resources are secretly somewhere, right? Like most of them are secretly in US East 1. And so there might be a way around that, but I'm sorry, I don't have a better answer for you, Stephen.
Okay, maybe you can help Mohammed here. His question is, if we use the old Glacier, will that automatically switch to instant retrieval?
Yeah, that's a good question, and no, it won't. What the old Glacier will now just be called flexible retrieval. And so if you want to switch it, you would have to go and, actually initiate a transfer of those storage classes. And that's kind of the annoying thing with the old Glacier, and that still exists. Yeah.
Here's one from Victoria. How does Incident Manager compare to third-party incident management tools?
Yeah, that's a good question. As I said before, really, Incident Manager is very focused on just AWS stuff, right? So it's really going to be triggered by things within AWS, CloudWatch alarms, and Event Bridge. And I think you're going to have a hard time if you want to have it automatically trigger from non-AWS things. And I think that if you are integrating teams that don't spend most of their day in AWS, then third-party tools are probably still going to be much more robust. Incident Manager is still relatively new. But as I said, if your team is relatively small and you're focused on AWS, that's Incident Manager's sweet spot from my perspective.
Gotcha. Edward is asking about, he says, is this similar to Azure Cold Storage? Edward, I'm not sure what you're referring to. Maybe enter your question again. I know I should have tagged it when it came in, but
it's okay. I can try to address it.
All right. Okay. Cool.
Yeah. So the answer is yes, right? So Azure has their own tiers. They've got cold blob storage, and yes, Glacier is very similar to that. But I encourage you to look carefully at the limitations of a storage class before you select it, because oftentimes the fine print there really matters. Use the AWS calculator or Azure calculator to figure out what the cost differences are going to be. I recently had a customer in Azure who set their backups. They actually were just using Azure as a backup target. So they sent it to Azure Blob Storage. But they set the storage tier to globally redundant storage, like in the hot access tier, which is really not what you want for backups at all, right? They got charged so much money just in the first month that they canceled their entire Azure account, like completely. They're just like, we're not going to do it. We're just going to go on-prem. And that was sad for a couple of reasons, because now they're going to be turned off of cloud, right? Like that's the model of paying for what you use in the cloud is a double-edged sword, right? It's great if you're only paying for what you use, but it can also rack up big bills. And so they got burned. My experience with AWS is they're much more forgiving about that because they want you to stay in. And despite my best efforts with Microsoft, I wasn't able to get them even a dime back. So, so just be really careful when you choose a storage class. It is a significant decision, and it's actually harder to change later than you might think, especially if you choose like an archival tier like Cool or Glacier. Yeah.
Wow, lesson learned. Okay, here's one from Tim. He's wondering, can you replace on-premises AD with AWS managed Microsoft AD?
You totally can, Tim. There's some limitations that you will want to be aware of, but you really can. I just did one recently. I set that up for a customer where we had to deal with a lot of complex DNS routing rules, right? Because now we wanted to have internal DNS resolution, both inbound and outbound. And so that's totally possible. It gets, you need a good architect for that, and, reach out to me if you want one. But you totally can. One of the things that's nice with the managed AD is that, an enterprise managed AD, you could have geo-replicated, right? You can put that in two regions if that's important to you. It comes with high availability built in, and that's really nice. But some of the limitations you'll run into are things like you don't actually have full control of that AD like you do on-prem. So you get a user that's technically administrator, but is like a delegated administrator. And so you can't, for example, extend the AD schema just by kind of logging in as domain admin and going to the schema editor like you would on-prem. You have to write an LDIF file and apply that through the AWS console. Now, AWS is doing that because they're trying to force you to be careful to not break your schema, So there's a good reason for those things, but it can be a bit of a shock if you are used to being the guy on-prem who has full control of your AD and you know how to use everything from your Windows box. And then the other warning I'll give you, Tim, is just be really careful to design your network and directory structure like upfront, because you can't change that later, right? Like if you decide, okay, I'm going to use a different fully qualified domain name, or I'm going to put this in a different network or something like that, there's no way to move that. It's going to require replacement, and a lot of those configurations within AD will just be wiped out. So one of the major things that I do as an architect is help you figure out what things are going to be hard to change later, right? So you can get those up front. And in cloud, a lot of stuff you can change later, right? You can tweak configuration, but a lot of these things that were not really cloud native, like AD, it's so hard to move later. So just be careful about some of those key decisions.
Okay, well, maybe we've got time for one more question. This one from Vic. How do you recommend getting started with a migration into AWS?
That's a good question. We looked at the application migration service, and I want to be careful that I don't make it look too easy to do a migration into AWS, because there's a lot of things to consider, right? There's a lot of things to get right in setting up your AWS account structure, management, and security controls. And those are things that you really, really want to get right up front. Setting up who's going to manage this, how are we going to authenticate into these things. So those are all important things that you want to think about before doing it. But really, I recommend connecting with an AWS partner like my employer, Intervision. We've done so many of them, right? We've done like 50 or something in the last year that we just have a lot of lessons learned. And our goal is to help you ultimately own your environment, but we'll get you there and get it done, right? Because you don't want to get stuck midway because your team just doesn't have the AWS experience. And then the other piece of wisdom I'll pass to you is that as you're doing a migration, it's a really good time to challenge a number of assumptions and tools that you have built over time with your on-prem world. You might have security tools that help you manage your virtual machines. It might be time to replace those as you go into AWS and use AWS Systems Manager, for example, for patch management and remote access. Actually, one of the things that didn't make it into this list is a new feature from AWS Systems Manager called Fleet Manager, where you can remote desktop into any of your instances, even if they are on a private IP, right? So it's in a private a subnet, and I don't have a VPN into it. Well, AWS, using its agent, will give me a remote desktop connection to that, and I can't tell you how useful that is, compared to having to worry about remote management tools. So it's a great time to challenge a number of assumptions and kind of clean up what you've got. Pretty much every customer I have that does it is so much happier with their end state compared to what they had on-prem. So go for it. Yeah.
Stephen Smiley, thank you. That was an awesome session, as promised.
Awesome. Thanks again for having me, John. Appreciate it.
Okay, folks, looks like that's all the questions we have time for. Many thanks to Stephen Smiley for a great session, and to our sponsors, SUSE and AlertLogic, for making it possible. We're going to take a short break now, but we'll be back at the top of the hour for our second session, AWS Security, Backup, and Recovery Tips and Best Practices, which will be presented by the awesome Carlos Rivas, Senior Solution Architect at Intervision Systems, and moderated by my colleague, the editor extraordinaire of Virtualization and Cloud Review, David Rammel. Now would be a great time to check out those extra resources on your console provided by our sponsors. And remember, during today's third session, we will be giving away a new iPad mini. This thing is so cool. But you must be present to win, so stay tuned. Back in a few.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers, my fellow moderators, and of course our sponsors, SUSE and AlertLogic, for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the second session of our summit called AWS Security, Backup and Recovery Tips, and Best Practices. Our speaker for this session is Carlos Rivas, Senior Solutions Architect at Intervision Systems, where he helps California community colleges move their traditional data centers to the cloud. Over the course of his career, he has worked for several large telecommunication providers, managing and configuring network devices using numerous tools and languages, including Java, Groovy, Python, Perl, and PHP. He's also a cloud computing instructor for LinkedIn Learning and Udacity. Carlos, it's great to have you here. Please take it away.
Thank you so much, David. It's always a pleasure to be here. And good morning, good afternoon, or good evening, depending on where you are in the world. And today, I'm going to talk to you about best practices around security and identity management. Also going to touch on disaster recovery and backups a little bit, and then of course we'll have the Q&A at the end. Particularly about identity management, I want to say that I'm going to try to set up a demo here for you guys so that we reduce the number of slides as much as possible. So if I can, I'm going to jump in my AWS console so that we can talk live about identity management. And like I said, just overall reduce the number of slides that you're going to have to endure. So let's get to it. So threats. That's something that's in the back of everybody's mind these days. It's a never-ending topic when it comes to threats, especially if you're in the cloud, especially if you have endpoints in the clouds that are facing the public. Threats are going to be, present all the time. We're talking about denial of service. We're talking about ransomware and all kinds of things. And, whether you're just one of those on-prem to private cloud, or you're on-prem to public-facing clouds. It really depends, but this is something that you need to be aware of at all times and know the tools that can help you mitigate these threats. So let's start talking about load balancing and firewalls. Firewalls, it's something that, yes, of course, you think about security as soon as you hear firewall, especially in the cloud. Load balancer, not so much, but yeah, I'm going to give you the reasons why I consider a load balancer as a tool to mitigate threats. So let's start just with a little bit of definitions here. So a load balancer is essentially a way to distribute the workload across your fleet. Now, how can it help you mitigate a denial of service attack? Well, you could say it can help you send traffic to various instances that may or may not autoscale, and we're going to touch on that a little bit later. But a load balancer, especially if you use a service load balancer provided by Azure or AWS or whichever your cloud provider may be, these tools are going to help you filter out traffic. So, for example, if you're under attack and you can see that it is non-human traffic, just bots trying to take down your infrastructure, because you don't manage the load balancer, you can just communicate to your cloud provider, in this case AWS, and tell them, hey, I'm getting all this traffic. Can you do something about it, right? And that's when a load balancer becomes a tool for threat mitigation, because they can see what's going on and they can help you filter these bot traffic that is attacking your infrastructure. When it comes to a firewall is obviously more specific to threat mitigation, and in the case of a firewall, it kind of falls on you to filter out traffic, because you're using it to be able to identify, hey, this entire subnet is a bunch of IPs that is generating traffic into my web server, but I don't want it. It seems to be illegitimate traffic, and you can control that. So you don't need to open a ticket or contact AWS or anything like that. It's something that you can do yourself. Now, this is more or less what it looks like. Something of it's a reference infrastructure. So you would have like a load balancer, and that load balancer can send traffic to potential firewalls, and then from there to another load balancer, and this one is an internal load balancer, which in turn sends traffic to web servers. This is more or less like in your front door of your house, for example. If you have more than, let's say you have a deadbolt and you have a key entry, those things, maybe perhaps a little chain like in the hotel stores, all those little layers, when combined, they provide extra protection for you. So that's why you see several layers here of load balancing and firewalls as well. Now, I mentioned autoscaling. So how does exactly autoscaling help you when it comes to threat mitigation? In fact, people would be arguably kind of scared to use autoscaling for threat mitigation, because when you get all these denial of service traffic and your infrastructure starts scaling up, you would have an issue with all this traffic and all this scaling. Okay, it's going to cost me a lot of money. What do I do? Well, I'll tell you right now, it's probably not going to cost you money, and you shouldn't be afraid to use autoscaling as a tool in this case, because as soon as you identify the traffic as being illegitimate traffic, you can open a support ticket with AWS, and they'll remove that autoscaling expense from your bill if you can prove that it's actually a bad traffic, not your users using the application. So if you can prove that you are under a DDoS attack, and usually they know it, you don't even need to tell them, you can use autoscaling, and they won't charge you anything else for it. This is a little bit more of a formal way of doing things. So this is more of what I call a reference architecture. So you would see this setup like this, where you have your users hitting your Route 53 endpoint where you host your domain names. And then from there, you can send them to several layers of CloudFront and Web Access Firewall. And perhaps you're also using AWS Shield as part of your protection layer. If the user can manage to get through this, that's a good thing. That means they're probably a legitimate user, somebody that you want to see accessing your website. Then you can route them to your normal auto-scaling and your load balancer as well. So this is the type of setup that you want to use. If you have nothing, let's say that you just using your personal AWS account to run a WordPress blog, for example. You could set it up just like this. It's not going to be that much more expensive than just running it by itself on an EC2 server, and you're going to be very well protected against these bot attacks. So let's switch gears a little bit and talk about disaster recovery. When it comes to disaster recovery, the number one thing you're going to have to think about is how fast do you want to recover? Obviously, time is money, right? So you want to be able to understand what are the requirements when it comes to the design of your disaster recovery solution. Something that I have here is called an air gap, and this is very specific to recovering from a ransomware attack, for example. Let's say something happens to your backup, something happens to your server. Somebody came in and encrypted your information, right? Like, what do you do there? You have no way, they have the key and they're asking for money. Otherwise, they won't give you the decryption key. Now you're in trouble. What do you do? Well, an air gap solution is essentially a way to be able to send your backups or your information to an isolated environment, right? And in this environment, your backups are safe and pretty much inaccessible. It's kind of like a one-way backup. There's no way to retrieve this data, right? So if you get hacked for whatever reason, the hackers will not be able to touch the data that you sent over the air gap. This is more or less what it looks like in a diagram form. You have your connections, and then at some point there's a firewall, and you send your data over that firewall. And like I said, there's no way to pull that data back. So anybody that's trying to read that data, they won't be able to, because it's on the other side essentially, and it's not really retrievable unless somebody actually intervenes to make it happen. Now, getting a little bit more specific again about disaster recovery, as I mentioned, the factors that are going to determine what design you go for are going to be whether you need things really, really fast, which is called a hot standby, essentially a working, functioning copy of your production system. Of course, this is expensive because you're essentially doubling up on everything. Or, you can go to, let's say, a warm standby, which is going to give you a little bit, more downtime. So it's going to be a little bit cheaper. But in that design, you're going to have not something running all the time. Perhaps you have your machine image, your snapshots ready to go, and you're going to spin them up when something happens, and they're going to be located perhaps in a different cloud provider, or if you're using the same cloud provider, perhaps do it in a different region, for example. And I keep mentioning potentially another cloud provider because in recent months, there's been, at least that I can recall, a couple of incidents in AWS when they went down for several hours. And we're talking about taking the whole internet with it. I mean, you can't do online banking. You can't do any shopping, anything like that. All those things go down at the same time. And if you run a business that cannot afford to be down for several hours, when things like these happen, it's potentially best to have a warm standby setup in a different cloud provider. Just something to consider. Finally, cold standby, which is essentially a backup, pretty much just a backup, something that you can pull and restart your service with. And the cold standby is essentially data in storage, right? Using one of the popular stores such as S3 or EBS snapshots or something like that. and then you keep that away. And if something happens, it's going to take a while to restore that and bring your service back online using this data, but at least it's there. And of course, this is the cheapest solution when it comes to a disaster recovery infrastructure. Speaking of the most expensive solution, this is a setup that looks like for hot. This is actually for hot standby. So imagine that you're using AWS RDS service for your database in production. So in this setup, what they do is they'll set you up with 2 different data centers, 2 availability zones, and one is going to have your main copy, and then the other one is going to have your standby. In this case, what you do is actually do nothing. You essentially just pay for it, and everybody's going to access your main database, of course, and there's going to be a synchronous replication going on behind the scenes at all times. So if your database crashes for whatever reason, you can just go to the standby. And in fact, RDS will monitor itself. So if the main goes down for whatever reason, it will automatically switch to the standby replica right away. And as I mentioned, this is for hot standby reasons, meaning that this is, when it comes to databases, this is the most expensive setup that you can have. But of course, it's also the most time efficient. So you can recover from a disaster pretty much instantly. Even your users wouldn't even know something's going on if you choose this particular route. All right, let's take a look at this. This is, of course, as you can see, it's getting a little bit more and more complicated as we go along. This is what I call the reference design for a hot standby. Essentially, 2 copies of your same application. And they're running in perhaps in different regions. In this case, of course, it's just using AWS. So you can have this in one region, let's say the East Coast, and the secondary copy perhaps in the West Coast. And so the question is, how do we know, if something happens? Well, Route 53 offers health checks. They have a health check, and the health checks will periodically check whether your load balancers are there, your EC2s are there. If something happens, you can just make a little switch in Route 53 or use the health check to make that decision for you and, and send everybody to the other region. Because more often than not, what you can do with this setup is you can have somebody based on their geographic location. Okay, I'm going to send this traffic to the West Coast because this particular user is closer to the West Coast. If you have a user in New York, for example, you'll send them to the East Coast copy of your deployment, for example. But, let's say that the health check in Route 53 is reporting that the West Coast data center is down for whatever reason. Actually, let's switch it to the East Coast because that's mostly when AWS have problems. It's in US East 1. So if we have a problem there, Route 53 can detect that the health check is failing, so it will send all the traffic to the other zone. And of course, as I mentioned, this is the most expensive disaster recovery setup, simply because you are doubling up on everything that you have. 2 load balancers and 2 auto-scaling groups and so on. So everything is kind of double in this case. Except if you look at the bottom, when it says DynamoDB Global Tables Automatic Replication, this is kind of what I was talking about in the previous slide here, that you have that database has the capability to replicate itself. This is not RDS in this example. This is DynamoDB, but it's essentially the same thing. You can have that data in the East Coast automatically replicate to the same table in the West Coast. So, moving on from there, this is the one that I call the AWS Framework Reference Architecture. And this is more or less the setup that you would have kind of like starting over. Let's say that you want to do that disaster recovery, but you want to back up a little bit and you say, hey, I have nothing in the cloud. I'm starting over. I want to start from scratch with a clean reference setup, this is the kind of setup that you would do. You would take your main account where you have your billing information, and you would use that to create an AWS organization, and that organization is going to have various accounts that you can use for other purposes. Let's say in this case, a log archive. You would put the log archive in that particular account, and you would obviously set appropriate permissions and access to these logs based on needs. For example, for auditing or something like that, you would provide access to these account only. Share services. When it comes to share services, usually something like Active Directory comes to mind. This is something that you provide, and probably a lot of people are going to use it for their own internal applications or authentications or single sign-on and all that stuff. So you will have that in a share services account. And of course, when it comes to security, that's where you're going to have the most restrictive access, and that's where you're going to set up tools such as guard duty or SNS notifications to production support cell phones and things like that. You would set that up in the security account. So like I said, this is reference architecture. We can certainly talk about this. You can reach out to me on LinkedIn or something if you have questions about this, because this is a very standard setup that pretty much everybody does at the beginning when they're brand new to the cloud and they need a setup. This is more or less what it's going to look like. So where can I learn more about this particular setup? Well, everything I just showed you comes more or less from the AWS recovery in the cloud. This is a disaster recovery white paper that they publish, and they keep it updated. That's what I really like about AWS, that they keep their information as up to date as possible. And the framework that I just described is called the Wall Architect framework. And again, that's also something very updated frequently by AWS. Not only that, but they also have something called AWS Control Tower, which you can use to actually deploy I believe they call it a landing zone. Basically, everything I just showed. Actually, let me go back a little. So if you wanted to do this entire infrastructure, well, not entirely, but about 80% or 90% of what you see here, you can just set it up with AWS Control Tower just by going in there, maybe a couple clicks, and it will do it for you. So some tool to consider if you're brand new to cloud and you want to do that setup. Now let's switch gears a little bit and talk about backups in AWS. The first tool that comes to mind is AWS Backups. This might be a little overkill if you are new to cloud, but let's talk about it. AWS Backups is essentially a tool that you can use to create backup plans. That they're going to have retention policies, they're going to have backup frequencies, and so on. And because this is their main backup tool, it's designed to support a series of AWS services. In this case, EC2, CVS, storage gateways, the database that we just mentioned, whether it's RDS or Dynamo, and various file systems as well. Now, as I mentioned, this tool may be overkill for some of you because this tool is kind of designed for like really larger type of operations, so something to consider there. What I recommend if you have a small infrastructure, let's say that you have 20 servers or less, you're not using many services in AWS, you essentially have, as I mentioned, web servers, perhaps a database server, perhaps an Active Directory. I recommend the Lifecycle Manager, which is essentially a tool directly available in the EC2 console. You can go in there and establish a backup schedule. You can also create AMIs from your machine. So, and this is really important when it comes to, let's say, a warm standby. If you want to have a warm standby or a cold standby, you can take your backups and turn those backups into AMIs, which is a machine image that you can spin up in case of a disaster. Not only that, you can take this information and send it over to an air-gapped environment, just as I mentioned, to protect yourself from potential ransomware attacks. So this is probably more than enough when you're starting out. So just remember, the big one is AWS Backup, and the smaller one is called Data Lifecycle Management. This is another setup that I like to mention because most people, when they start using the cloud, it's usually because they want to protect the data that they have on-prem and send it over to the cloud. And what I recommend in this case is something called the AWS Storage Gateway, which is essentially a virtual machine or appliance that you deploy in your local VMware environment. And what it will do is essentially keep everything, on a synchronized schedule. It will do a backup. Let's say you set it up for every night or something like that. It will, keep track of the machines, the snapshots, and make backups and send it over to Amazon S3. Of course, for this to happen, you need to have an infrastructure in place, meaning you have to have some reliable connectivity from your site to AWS in this case. But once you take care of that, whether you're using a simple VPN or perhaps a direct connect to the cloud, once you take care of that, this tool is completely seamless. It's pretty easy to use. And then you can send your data over to AWS in this case. And then once the data is in AWS, you can talk about storage classes. Let's say that you don't need that data right away, and you'll never need it right away. You can choose something like Glacier, which is AWS cold storage. And in that case, if you have cold storage, it's going to cost you pennies per month per gigabyte. So it's something to consider as well, especially if you're backing up directly from on-prem services. There is one more solution that I'd like to talk about when it comes to backing up your data, especially from on-prem, and that's the third-party solution. I'm not going to name any names. There's plenty of these that are very, very popular. And essentially what they do is pretty much the same as I just described here in the storage gateway. So what that means is there's going to be some type of agent or software running on your on-prem environment, and it's going to require that you have previously established connectivity to the cloud, whether it's directly over the internet, perhaps using a VPN, or the most ideal, of course, is having an actual direct connect to the cloud, which is obviously the more expensive, but it gives you the highest bandwidth possible and security, of course, once you have direct connectivity from your internal network to the cloud. Anyways, once you set that up, you can run this software, and it will do exactly like I said, just like Storage Gateway. It's going to run and monitor your environment, and it's going to send the data over to AWS. In fact, some of these programs, I think Zerto is one of them, that can not only send to a single cloud provider, but it can send it to other cloud providers at the same time. So, you will have that hedge there in case something happens to AWS. Your data can be, let's say in Azure as well. So if you can't recover from AWS in time, you can switch your recovery to a different environment as well. And it works. This is really cool. So if let's say that you're simulating a disaster recovery right now, like you want to practice your situation, what you can do is you can have let's say a blank slate in the cloud, and you can use a third-party software like this and say, hey, let me recover my entire environment to this little network that I just created here, and you can simulate as if a disaster happened and have your servers be restored to this new environment. The advantage of this, and I shouldn't say advantage because it should be mandatory, is that you get to practice an actual disaster recovery. Something that I like to emphasize is that if you don't have practice doing your disaster recovery, you don't have a disaster recovery plan. Simple as that. Something that you need to practice all the time so that when it actually happens one day, you will be ready for it. So just something to keep in mind there. Now I'm going to switch over to my AWS console. Let me see if I can share my screen here. I want to show you something. Window. All right, so I have my AWS console here. And what I want to talk about now is identity management, because it's just something that's so important when it comes to security. I'm going to click here where it says AWS Single Sign-On. And this tool is going to help you avoid having to create users all over the place. Most people that go into the cloud, they're going to have some sort of identity provider already set up. For example, I can tell you that in the education sector, a lot of people use Google Suite for the students. So they're going to have all their IDs, all their passwords, all their emails already in this one source of information. So why, if you're going to set up a cloud application, why would you need to duplicate this IDs? Let's keep everything centralized and easy to manage in one location. Now, outside of the education sector, perhaps in the normal traditional business sector, most people will either have something like Azure AD or a traditional Windows-based Active Directory server. Again, the same thing applies. You have all your identities there, all your passwords there, all your policies, perhaps enforcing something like multi-factor authentication, all those things in one place. So if you want to install a third-party application, like using AWS or perhaps GitHub or something like that, you don't want to be that guy that says, oh, you're going to need additional passwords for these folks that are going to be accessing this application. It's just really annoying, and it creates an additional point where security can be an issue, because now people have to remember more passwords, and they tend to write it down in Post-it notes, if you know what I mean, and that creates a very insecure environment. So this tool, AWS Single Sign-On, I'm going to click here where it says choose your identity source. And it allows you to bring in all of those. In this case, I have it set up to use the internal security mechanism that it has for users and groups. But, it's something as simple as I want to change my identity source. I can click here and click on Change Identity Source. And right now it's set to internal AWS SSO. But as I mentioned, if I have an outside source, such as Active Directory or similar, I can just set it up here just as quick. And the third option here is the external identity provider. I'm going to click on this to show you something. As you can see, it gives me the option to download metadata file or to upload metadata file. Now, what is this? Most identity providers out there, they're going to support the SAML assertion language, which is essentially an XML that contains a security certificate to authenticate communication back and forth, and it's going to have a series of URLs and attributes. And these attributes are going to vary depending on what the goal is. It could be just a username or just an email, or also the role of the person. Is this person a read-only user? Are they a system administrator? So it really depends on what the goal is. But my point is, as long as you have a provider that supports the SAML assertion language, it doesn't matter what it is. You can connect it to AWS Single Sign-On one way or the other. That is, you can use AWS SSO as the source for that application, or the other way around, as I mentioned in the education sector, where you have all these users already declared in a Google Suite database, for example. You can just upload that metadata here, and then SSO will use that as the source of information. I'm going to cancel out here. Another thing, of course, that applies all the time is to have groups. I have a user here. I'm going to show you my own user, but I don't set any permissions to that user directly. What I do is I create a user group, and then I manage all permissions directly here on the group level, right? So anything I want to do, I never do it directly at the user level unless there's a very particular reason to do so. you want to manage everything based on groups, which makes it a lot easier for you. All right, going back to the main screen here. The other option here, option number 2, is to manage SSO access to your AWS account. So if you have various AWS accounts, you can set them up here, and this goes back to what we were talking about earlier about setting up a reference architecture where you have something like a security account, a log account, a backups account, a shared services accounts. And all of those accounts are going to require 100% for sure different levels of access to each. So you're going to have groups defined here in this application so that you can manage users accordingly and revoke or allow access to these environments directly from here. So you don't even have to log in to those accounts. You can manage cross-account access directly from here. And it used to be a pain to do cross-account access for AWS. But as I mentioned, if you use a tool such as AWS Control Tower, you should be good. It should take you no more than a few clicks to manage access to all of those environments just using something like this. And now option number 3 is where things get interesting. It says manage SSO access to your cloud application. And this is what I was talking about. Anything that is SAML 2.0 compatible, you can essentially manage and control from here. And this is absolutely great. You can, let's say that you are a PHP developer or a Java developer. You can say, well, is there a library that supports SAML 2.0 for my own code? And the answer is probably going to be yes. I'm not quite sure about Java, but I'm pretty sure for PHP there's a library out there that you can integrate into your application. Imagine being able to write your own code, not have to worry about a user password dialog or something like that. You can just integrate it to your own company's single sign-on, and then boom, that's it. You just gave yourself authentication management, user management, and you don't have to do that because it's managed externally through something like this, like an SSO tool. So not only that, but a ton of applications out there already support this. I'm talking about tools such as GitHub and everything like that. So they already support this, so it's really good to have. At the very bottom here, we have the user portal, and I'm going to show you what that looks like. I'm logged in with my user, and you see there's only one application here, and it's GitHub. Actually, let me go back to SSO to show you this. I can go here to Applications, and you can see it says GitHub here. I'm going to click on it, and it's essentially exactly what I described. There's some metadata that was set up here, and a sign-in URL, a sign-out URL, and there's a security certificate, of course, to authenticate between AWS and GitHub. There's a property here that says session duration 1 hour, meaning that after a certain amount of time, you will be logged out for security reasons, and you will have to redo your login token. And then at the bottom, there's several URLs that tell AWS SSO where to go once the authentication takes place. And this is pretty much standard. I'm using GitHub as an example for you guys, but it could be absolutely anything that supports SAML 2.0. And this is part of the what I was talking about, the attributes. In this case, GitHub, for example, is going to require user email and this particular information. I think that's all they need, really, email, to be able to authenticate the person on the other side. And of course, for the sake of AWS SSO, so once somebody logs in this case, you can manage by user or by group. So for example, I have here the developer group. So if somebody logs into SSO and they have the developer, a group assigned to them, they're going to be able to see this application in this case. Let me go back to the screen here. Like I said, you'll see GitHub here, and I can just click on it, and let's see what happens. You see it flashes GitHub SSO, and it drops me here. You see, I wasn't asked by GitHub about any user or password, just drop in directly here in this management console. Oh, and by the way, this feature is only available in the GitHub Enterprise version, so you cannot practice this with your personal GitHub. Actually, I take that back. You can, but you need to upgrade your personal account to the trial. They have a trial for the Enterprise version of GitHub, and once you do that, you will be able to, replicate something like this and be able to test it if you're looking to do something like this. Let's go back to the portal here. Yeah, as you can see, it's pretty much straightforward. Because all these settings that you're looking at are pretty much standard for any third-party application that you want to set up with an AWS single sign-on. Oh, and this URL that they give you is a really ugly URL, machine-generated name. But of course, you can use something like Route 53 to change this name into something more meaningful for you. So, let's say example.com/myapplications or myapps.example.com, for example, if you wanted something more meaningful to you instead of this number-generated URL. One last thing I would like to point out before returning, it would be the identity source. In this case, what they have, I believe what they have is some sort of internal AD type of scenario. So if you're using SSO directly, which I don't recommend, for example, I can click add user here and create a user. Like I said, I don't recommend this. Most people that use this, they already have some sort of identity source, whether it's their Active Directory or Google Suite or something. But if you absolutely have to use this because you don't have any other source of centralized identity management, just know that this is right here, and it's more or less like an AWS Active Directory that just links up directly to SSO, and you can use it as your identity source. All right, let's get back with our presentation here. Let's see. This is the overall architecture. So this is what it looks like behind the scenes. You have your AWS organization, as we mentioned, like your security accounts, your share services, and all. One thing, as I mentioned, that you could use SSO. This is something that you can practice. SSO can only be set up at the top level. So let's say that you belong to a company that is already using AWS organizations, and you have access to one of the accounts, so let's say a practice account or a sandbox or development environment. You will not be able to set up SSO there. You will need to ask your system administrator to do it for you because this can only be done at the top level of the organization, of the AWS organization. So if you really want to practice this, I encourage you to do it on your own personal AWS account. This is a lot quicker to set up if you do it in your own environment because you have 100% control and you have root access and all that stuff. So it shouldn't be a problem to set up in your own personal accounts. Another thing I didn't get to touch on when it comes to AWS SSO is something called permission sets. A permission set is essentially exactly what it sounds like. It's a set of permissions that is going to, be assigned to your groups so that you don't have to worry about specific users. You can set up a permission set that only includes read-only access to various accounts or, only access to backups for one group, one particular person or something like that. That's something that you can do directly in SSO. And this is independent, by the way, from user identities. So you can have these permissions and assign them to groups. And, as you move people around, they just keep those permissions tied to the groups. Just something to keep in mind. And, of course, the two things that are most valuable to me when it comes to SSO is number 2 and number 3, being able to set up third-party applications to use something like this. And, of course, being able to write your own applications, as shown here in number 3, so that they can take advantage of your already existing identities. Now, before I let you go and we do a little Q&A, I would like to talk about some few key points before we walk away. Number one, have a backup strategy. That's kind of useful. Number two, have a disaster recovery plan. And always remember that if you don't practice your DR plan, you don't really have a plan. You need to be able, if you create a disaster recovery plan, you need to practice that over and over so that when it actually happens, that your system goes down, you know exactly what to do, and you've already seen any potential issues and scenarios along the way. Also remember, CloudTrail is your friend. When your boss comes to your office and asks what happened and who did it, CloudTrail is your friend. Always remember to enable that day one where you're using Cloud, because it will show all the entries, all the activities, all the API calls that happen in your cloud environment. So be sure to use that tool as often as you need to. Firewalls, firewalls are your friend when it comes to protection against live threats, such as denial of service attack. So be sure to set it up, especially if you have a web-facing application, public-facing web servers, things like that. Firewalls are your friend, so remember that. And what actions can you take right now, right after we're done here? Number one is to enforce MFA, enforce multi-factor authentications. If you don't have it, if you rely only on usernames and passwords, that's the old way to do things. You should not be doing that in 2022. Lock away your root account for your cloud environment. You don't need it. That's a bad practice to use the root account. Just like if you're managing a Linux server, you shouldn't be using the root user unless you absolutely have to. Just use normal users for your activities, and your root accounts should be reserved for billing purposes. So just keep that away. And reduce entry points into your environment. That's the number one reason for using AWS SSO, is so that you're not going to have a bunch of users all over the place, like IAM users and, something else. Just have that one centralized access point so that, if somebody leaves your organization, you can just shut them down in the AWS SSO and not have to worry, oh man, this person had another password for GitHub or another password for this other thing. If they're just declared in one place, you just need to shut them down in that one place, and then you're safe, right? And on that note, avoid using IAM or Identity Access Management user accounts in AWS. Use something like AWS SSO, which provides a lot more flexibility. You will need IAM users, of course. Even if it's just for disaster recovery reasons, you're probably going to need it. So that's always going to be there, but don't get in the habit of assigning those users to people. And speaking of people, if you have servers that require permissions to access data, you should have those servers set up with IAM roles instead of, API keys assigned to users. That is a really bad practice to have IAM users with API keys that have access to your environment. You should prefer IAM roles instead in that case. And that's what I have for you today. Really happy to answer questions, so fire away.
Okay, great job, Carlos. We do have some questions, and we'll get right to them. But first, I'd like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session. So let's dig right in, and we'll start with first come, first serve. So in the Q&A box, Carlos, if you're following along, the first question comes from Eric. He asks, is there a simple backup solution for serverless apps?
That is a great question. Let's talk about serverless for a second. Serverless are still going to use the standard backends, and by standard I mean something like RDS for database, or DynamoDB most likely, something like that, or perhaps generate actual files, and those files are going to end up in an S3 bucket somewhere. So when it comes to backup for those things, when it comes to databases, yes, they're ready-made solutions for that right away. I can just think of AWS backups, for example, that I just mentioned. When it comes to S3, you have to configure it, but it has its own thing that you can say, I need this version, or I need this S3 bucket replicated to another region for security reasons. you can set those up like that. It is absolutely possible. It's nothing necessarily tied specific to serverless, but yeah, I'm talking about the data that those serverless applications will generate. And yeah, there are solutions out there ready-made for that.
Okay, makes sense. Continuing the backup theme, the next question comes from Brian. He says, I have 4 terabytes of data to be backed up to the AWS Cloud. What is the fastest way to get this into the cloud?
When it comes to terabytes and petabytes, I usually recommend paying the money for Snowball, which is the device that AWS sends that you can plug into your internal network on-prem. And, well, you might say, well, this is going to take, they're going to ship it to me. It's going to take a couple of days to get to me. And then I'll do the backup, which is going to take another couple of days. And then in a couple of days back on UPS, back to the AWS data center. It's several days, I get it. And it may not necessarily apply for 4 terabytes. But when you do the math based on the available bandwidth, network bandwidth that you have, you may end up, consuming the same 3, 4, or 5 days transferring data over the wire anyway. So, yeah, I highly recommend the Snowball devices that AWS has so that you do the backup the traditional way, which is do it by hand and send the hard drive over to them.
Okay. Is there a threshold that you usually use for the amount of data before you recommend going to Snowball, or do you just have to do the math and compute the cost for each individual use case?
I don't think the cost is a factor here. That thing is really cheap. It's just a few $100 to have it sent to you and sent back. When it comes to threshold, I would say anything like 10, 20 terabytes is already too much to be sending over the wire. Some people have, that I've worked with, has like 80, 110 terabytes, and at that point there is no question. You have no other way to send it but to use this physical device.
Okay. Moving along, the next question comes from Anurag, who says, what if DynamoDB is not an option for me? Are other services providing similar resiliency?
Yes, most standard traditional SQL-based databases, they have the replicas that you can set up. But if you need to be something like DynamoDB, there's something called AWS DocumentDB, which is essentially a spin-off of MongoDB. And it does the exact same thing. It works exactly like DynamoDB, and it has that functionality that you're looking for. So I would strongly recommend you look at that if you need a NoSQL database, and then have that option behind the scenes to be able to have AWS manage replication and reliability and scalability and all that. So it's called AWS DocumentDB.
Okay. Next question comes from Niti. I hope I'm pronouncing that right. He says, in a typical telco-grade application running on AWS infrastructure, who should take the ownership for providing the TOR switch, data center edge, and the layer 4 load balancer? Would it be CSP or AWS or the packet core vendor?
When it comes to load balancers, if you're talking about layer 4, I would say there's something called an AWS network load balancer, which doesn't care about the application that you're running. So the application load balancer, or ALB, that's a layer 5. A layer 4 would be a little bit below that. And for example, in this case, the NLB, network load balancer, doesn't really care about what you're sending over. And to answer your question specifically, this is managed by AWS. You don't have to worry about it. You can use it for your own applications. Maybe in my life, I've seen maybe 1 or 2 uses when a network load balancer applies. It's really an interesting tool to use. Because like I said, it doesn't really care what you send to it. It's just a pass-through in this case. But yeah, that's the tool that I would recommend, network load balancer. And it falls under the umbrella of AWS, so they manage it. If something happens, you blame them. You can open a ticket and have them look at it. So it's a great thing to have, so you don't have to worry about that additional component there.
Okay, great. Next question comes from Alfred. What things do I need to be concerned with when implementing SSO using on-premises Active Directory when I now have all the access granted through IAM?
That's an interesting question. You have a bunch of people already, and now you need to migrate them over to SSO. Interesting. What I would do is I would define permission sets first. That's the very first thing. In other words, identify each person as a job role. So some people that are read-only will stay read-only, so you create a read-only permission set. Some people need full access use, so you will create another group called permission set of full access, perhaps system administrator. And then slowly you can define those groups and permission sets. Again, I'm not talking about people just yet, just defining groups and permission sets. Once you're happy with all this, you can then go ahead and say, hey, I'm going to block your access. I'm going to send you over to SSO, and I'm going to block your IAM user because I already have the exact permissions that you have over there, and I'm going to assign you to group X for this reason. And you can do that one by one. Never do everybody all at once because then you may have a real problem in your hands. But you can do one by one like that, or at least, perhaps similar job roles all at once if you want to do it in a more efficient way. But yeah, just like that. That will help you do it in an incremental fashion and not like a cutoff everybody on the same day.
Okay, looks like we have time for one more question. This comes from Abdul. I don't know if you can answer this one or not. He's asking, is Oracle Real Application Clusters, RAC, supported on AWS?
As a general rule, I will avoid anything with the word Oracle and AWS, mainly because they are bitter rivals. And in fact, Oracle, I believe, has offerings in AWS that are intentionally more expensive. So in order to force you to consider moving to Oracle Cloud. So unless you're talking about installing something like Oracle directly on an EC2 machine for legacy reasons, something that you would control instead of using an RDS Oracle and AWS. I don't even know if you can still do that. Yeah, that would be the only reason for me to use Oracle and AWS. Otherwise, I would strongly tell you to consider Oracle Cloud in this case if you're locked into Oracle.
Okay, great. Well, it looks like that's all the questions we have time for. So thanks again, Carlos, for a great presentation and answering those questions.
You're welcome. It was a pleasure.